Alright, so in this problem, I have 2 to the power of x plus 8 to the power of x equals 68. So I'm going to first rewrite 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x is equal to 68. And I can actually switch these two. So I get 2 to the power of x plus 2 to the power of x to the power of 3 is equal to 68. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y plus y to the power of 3 minus 68 is equal to 0. And this is the same thing as y to the power of 3 plus, I'm going to rewrite y as 17y minus 16y minus 68 is equal to 0. And now I get y to the power of 3 minus 16y plus 17y minus 68 is equal to 0. So I simply switch the places of 17y and negative 16y. And now from y to the power of 3 minus 16y, I'm going to factor out y. So I get y times y squared minus 16 plus from 17y minus 16, I'm going to factor out 17. So I get 17 times y minus 4 is equal to 0. And this is the same thing as y times y plus 4 times y minus 4. That's equal to y squared minus 16 plus 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y plus 4 plus 17 is equal to 0. And this is equal to y minus 4 times y squared plus 4y plus 17 is equal to 0. So now this gives me two equations. I get y minus 4 is equal to 0, and y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, y is obviously equal to 4, so I get one solution. And from y squared plus 4y plus 17 equals 0, you have to use the quadratic formula to solve this. And if you actually do end up using the quadratic formula, I'm not going to do it because it's a waste of time, but you get that there is no solution, but because you get the square root of a negative number, and you can't take the square root of a negative number. So y equals 4 is my only solution for y. And now remember how we let 2 to the power of x equal to y. So now if I have 2 to the power of x is equal to y, and y is 4, that means I have 2 to the power of x is equal to 4. And 2 to the power of what number equals 4? 2, right? So I get x is equal to 2. And this is my solution to this problem. Alright, so in this problem, I have x to the power of 4 is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus 4 is equal to 0. Now, I'm going to rewrite x to the power of 4 here as x to the power of 2 times 2. Now I have this minus 4, which is the same thing as 2 squared, is equal to 0. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite as x to the power of 2 to the power of 2. Now I have this minus 2 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So now I have x squared plus 2 times x squared minus 2 is equal to 0. So now this gives me two equations. I get x squared plus 2 is equal to 0, and I get x squared minus 2 is equal to 0. So for x squared plus 2 equals 0, I can subtract 2 on both sides, so I get x squared is equal to negative 2. And then I can take the square root on both sides because I want to cancel out this power. So if I take the square root on both sides, the square root of x squared is simply x, so I get x is equal to positive or negative square root of negative 2. And if you guys already didn't know, the square root of negative 2, I can rewrite that as the square root of 2 times the square root of negative 1. And the square root of negative 1, this is actually equal to the imaginary number I. So I get x is equal to positive or negative square root of 2i. Now for this, I have x squared minus 2 equals 0. I can add 2 on both sides. These two cancel out. And I get x squared is equal to 2. Now if I take the square root on both sides, I get x is equal to positive or negative square root of 2. Alright, so in this problem, I have 2 to the power of x plus 4 to the power of x is equal to 8 to the power of x. So I'm going to first start by rewriting 4 as 2 squared and 8 as 2 to the power of 3. So now I have 2 to the power of x plus 2 squared to the power of x is equal to 2 to the power of 3 to the power of x. Now I can actually switch the places of these two exponents. So now I get 2 to the power of x plus 2 to the power of x to the power of 2 is equal to 2 to the power of x to the power of 3. Now I can let 2 to the power of x equal to the variable u. So now if I replace 2 to the power of x with u, I get u plus u squared is equal to u to the power of 3. And now if I subtract u squared and u on both sides, I get u to the power of 3 minus u squared minus u is equal to 0. Now I'm going to factor out u, so I get u times u squared minus u minus 1 is equal to 0. And this gives me two equations. I get u is equal to 0, and I get u squared minus u minus 1 is equal to 0. So as you see, we already have one solution of u. So now to solve this, I'm going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I have u is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And this is equal to 1 plus or minus the square root of 1 plus 4 over 2. And this is equal to 1 plus or minus the square root of 5 over 2. So these are two more solutions. So now remember how we let 2 to the power of x equal to u. So let's first start with u equaling 0. So we have 2 to the power of x equals 0. And there's actually no solution to this because you can't take the power of a number and make it equal 0. So now we have u is equal to 1 minus the square root of 5 over 2. And 1 minus the square root of 5, that's going to be a negative number, and negative number divided by 2 is a negative number. And you can't take the power of a positive number and make it a negative number, so this is wrong as well. So finally, I have u is equal to 1 plus the square root of 5 over 2. And for this, I have 2 to the power of x is equal to 1 plus the square root of 5 over 2. I can take the log on both sides, so I get log 2 to the power of x is equal to 1 plus the square root of 5 over 2. So I can move this to the front, and I get x times log 2 is equal to 1 plus the square root of 5 over 2. So if I divide both sides by log 2, these two cancel out, and I get x is equal to 1 plus the square root of 5 over 2 log 2.